In Chapter 7, Section 4, continued, simplifying numbers with rational exponents. So this time in this section, we are going to take a look at negative exponents. All right, so if we do something basic like 3 to the power of 4, and then finally getting down to 3 to the negative 3 power, we look at a pattern. So 3 to the 4th, well, 3 to the 4th is 3 squared times 3 squared, and 3 squared is 9. 9 times 9 is 81. So 3 to the 4th is 81. And 3 cubed is 27. 3 squared is 9. And 3 to the 1st is 3. Now if we look at these numbers, 81, 27, 9, and 3, the pattern here is to get to the number below it, you divide by the base 3. Okay, so 81 divided by 3 is 27, divided by 3 is 9, divided by 3 is 3. Divided by 3 is 1. And we already talked about any non-zero base being raised to the 0 power equals 1. Okay, so if we continue on with the pattern, we will see that 1 divided by 3 is 1/3. And 1/3 divided by 3 is 1/9. And 1/9 divided by 3 is 1/27. And so what happens is this is really 1 over 3 to the positive 1 power. And 1/9 is really 1 over 3 to the positive 2 power. And 1/27 is really 1 over 3 to the positive 3 power. So when you move elements from the numerator to the denominator, or from the denominator to the numerator, it changes the sign of the exponent. Now keep in mind, the base will never change sign. Like, you can't move this 3 to the bottom and say it's negative 3. Okay, the only thing that's going to change is the sign of the exponent. We conclude here and say, so a, because a could be any number, to the negative m power is equal to 1 over a to the positive m power. And we can also conclude that 1 over a to the negative m power is equal to a to the positive m power. We're really just taking it from numerator to denominator. You should see that this number is in the numerator. It's over 1, yes? There's a 1 still up there because this is 1 times this. Okay, so when you move it, you can't forget about keeping the 1. And again, if I take this up to the numerator, there's still a 1 down here, and there's still a 1 here. Okay, so keep that in mind. I'll put a little star here and write some more notes. Remember, when I start having you turn in your notes, you've got to have all the writing. Move a base with a negative exponent okay, so we're going to take the base. Here's my base with a negative exponent. My base is a, the exponent is negative m. So move a base with a negative exponent to the denominator. Or numerator, okay, like this case, we moved it up to the numerator. To make the exponent positive. Or we'll say to change the sign of the exponent. And a big star only the exponent sign will change. Okay, so be careful that you're not trying to change the sign of the base. If it's negative out front, then it's negative out front in the bottom. It's just the sign of the exponent that's going to change. So, for example, if I have x to the negative 3, I'm going to rewrite this as 1 over x to the positive 3. See, expressions involving exponents are not fully simplified if you have negative exponents. They got to be all positive exponents. If you had something like 2 over 5y to the negative 2, I'm going to take my negative exponent and move it up. 5 does not have a negative exponent, so it stays in the bottom. This becomes 2 over, actually 2y squared over 5. Okay, so you take the individual elements, and this only works if you have multiplication. Okay, if you've got quantities, you can't do that. You typically won't see quantities here, but in the event that you would. All right, so why don't you pause the video and try the first 2 examples on your own. All right, hopefully you paused the video and found that 5 raised to the negative 2 power becomes 1 over 5 to the positive 2 power, which is 1/25. And in the next example, 1 over 5 to the negative 2, I move this up to the numerator. Remember, there's still a 1 in the bottom. I'm not going to write it over 1. It seems silly to write it over 1, because any number divided by 1 is any number. And 5 squared is 25. You'd always simplify. Let's take a look at the third problem on this page. All right, what do we got? X to the negative 2. Oh, that's got to go downstairs. So sometimes I'll circle these and give a directional arrow where I'm taking it. Y to the 4th, that's going to stay. These 2, however, they're going to get moved up. Now, don't forget, when you move them, you have to change the sign. So what's getting moved up? X to the negative 3 will become x cubed. Y to the negative 2 becomes y squared. And don't forget, we still had this y to the 4th. That didn't move, so it's got to stay up there. And the only thing coming down is x to the negative 2, which becomes x squared. All right, I got the same base. I got the same base here, and I have the same base here. I have to clean this up. I have to simplify it. So I'm going to do one step at a time. This becomes x cubed. Y to the power 6, right? Multiplication, same base. You add the exponents. And remember your properties of exponents. When it's division, you subtract them. Or you could say 2 of these will kick out 2 of those, leaving me with 1 left in the top. So my final answer here is xy to the power of 6. Okay, so if you have any questions, please don't hesitate to reach out and ask. Now we're going to put this together with rational exponents, and those rational exponents sometimes being negative. So in our example right here, we have 25 raised to the power negative 3 over 2. Don't try to do too much in your head to try to save steps. I mean, it's just easier if you write it down, and you'll be more successful because you actually can understand it better because you're going to see what you're looking at. I'm going to move this base to the denominator because the exponent is negative. So this becomes 1 over 25 to the 3 over 2 power. Now I'm going to convert this. Remember, this is power over root. So this is 1 over the square root of 25 cubed. Well, the square root of 25 is 5, so this becomes 1 over 5 cubed. And 5 cubed is 125. So my final answer in simplified form, 25 to the negative 3 halves power, is 1 over 125. All right, the next one. This one, notice there's no negative exponent, so I'm okay. I'm just going to convert it using rational exponent properties. Power over root, this is the 5th root of 32 cubed. Okay, the 5th root of 32 is 2, because 2 to the power of 5 is 32. Okay, so this now becomes 2 cubed, and 2 cubed is 8. So it helps if you know some of your basic higher powers, you know, like cubes and 4th powers and 5th powers. The next example. Students sometimes see a negative and they think they got to do some switcheroo here. But remember, you can never change the sign of a base. So all I'm going to do here is I'm looking at the exponent. The exponent is not negative. So I'm just going to convert this to radical form. Power over root, it's cube root of negative 27. And once I find that, then I'm going to square it, right? Here's my power, here's my root. Cube root of 27 is 3. This number inside the parentheses becomes negative 3. And since it's in parentheses, and it was in parentheses to start with, when I square negative, it's positive. So this answer is positive 9. Next example, we've got a decimal. This is negative 2.5. So what I'm going to do first, so I don't confuse myself, is write this as 1 over 25 to the positive 2.5. Now 2.5 is 2.5, and I want to convert that to a fraction, right? I don't want mixed numbers. 2.5 is 5 over 2, so this becomes 1 over 25 raised to the 5 over 2 power. Okay, or you could do 2 and 5/10 and convert that. You convert the mixed number to an improper fraction. All right, so what do we got here? Power over root. It's square root. So the denominator is square root of 25. And then raise it to the 5th power. Don't forget about the 1 in the numerator. Square root of 25 is 5, so the bottom now becomes 5 to the 5th. Don't forget about the 1. And you could use a calculator to do 5 to the 5th. That's 1 over 3,125. You could check your answers. It's never a good idea just to use the calculator to do this for you, because you won't learn the skill of what's going on. And as you move on in a mathematics course, you need these skills. But I can check my answer. I always only use the calculator to check my work. I'm going to put this in parentheses, negative 2.5. And I get this 3.2 e to the negative 4. That's really times 10 to the negative 4 power. Now I'm going to type in 1 over 3,125. And if these two numbers are equivalent, then this should equal the same thing. And it does. Okay, so you could check if you're right by getting the same decimal for your beginning problem and your ending problem. But again, you should never try to use the calculator just to do it for you. I'm going to be looking for steps in your work. All right, on to the next type. 2 more examples. You will then have some practice problems to do over the course of 2 days. All right, I got 8x to the 15th power. Raise that product to the negative 1/3 power. So both 8 and 15 are getting raised to this power. Well, I could change the sign of the exponent right away and write this as 1 over 8x to the 15th power raised to the positive 1/3. All right, next step, 1 over. This is 8 to the 1/3. And this is 15, or x to the 15 times 1/3. When you multiply these, you're going to get 15 thirds. Right? Because that's over 1, right? 15 times 1, 1 times 3, 15 thirds. 8 to the 1/3 power is really the cube root of 8. X to the 15 over 3, well, 15 is divisible by 3, so this becomes x not inside this radical, okay? X to the power 5. And cube root of 8 is 2, so this now becomes 1 over 2x to the power 5. Okay, so if you have any questions, please ask. This problem here. Now notice the negative, or the 2/5 is not negative. That exponent is not negative. This one is, but I have to take care of this before I can take care of this. You see, because if I move this chunky monkey to the denominator, it's going to change the sign of that, not these. Okay, so be cognizant of that. So I'm going to write this as 243 to the 2/5 power, and then y, this is over 1, and I multiply these exponents, right? 10 times 2 is 20. It's negative 20 over 5. All right, and this one is going to go to the denominator. Now we know negative 20 over 5 is negative 4. So I'm going to write my y to the 4th in the bottom, right? I just divided, moved it to the bottom, it changed the sign. 243 to the 2/5 is power over root, the 5th root of 243 squared. 5th root of 243, you could do that on the calculator, or you could take a guess and say, well, it's not that large and it's raised to the power of 5, so if 2 to the 5th is 32, what's 3 to the 5th? That's 243. Okay, so this number inside the parentheses equals 3. Don't forget about the squaring because we didn't take care of that yet. And one last thing to do is to square that 3. You get a 9 over y to the power of 4. All right, so hopefully you will not find the negative exponents too cumbersome. If you have any questions, please ask. Have a great day.